Hi everyone. I'd like to go over the review that I posted on Classroom just a little while ago. And this will kind of review the first couple of days, and hopefully we'll kind of come together at some point and hopefully just be all on the same page. All right. So the review starts out with find the exact value of the following 5 functions, 5 values. So for letter A, we want to find the exact value of sine 310. So for these 5, I really want to make sure that we review the unit circle and using the grid. So I'm going to go off to the side, maybe right here, and go over the unit circle and the grid of how to memorize your sine, cosine, and tangent. So with the unit circle, we'll go for the first quadrant, and we have our common angles, 30, 45, and 60. We have our 0-degree angle, which is also the 360. We have our 90-degree angle, 180-degree angle, and the 270. I'm going to change colors, and I'm going to plot the points that we have to memorize. You already know 4 of them. You know that in a unit circle, at 0, it's to the we're going to go right 1, up nothing. At 90 degrees, it's 0, 1. At 180, it's negative 1, 0. And at 270, it's 0, negative 1. Those are the x and y values you learned back in middle school. So those 4 quadrantals you should already know. What you don't know, what we learned day 3 of this unit, were these 6 fractions. And you're going to notice a pattern. They all have a denominator of 2. You should all be copying this down and pausing the video whenever you need to catch up. So they all have a denominator of 2. And the numerators go like this. 1, radical 2, radical 3. And then we go in the opposite direction. 1, 2, radical 3. 45 degrees is the only one that has sine and cosine that are the same. The other 2, 30 and 60, they're pretty much flipped. And I'm going to change colors again. Cosine is in the x spot. Sine is in the y spot. And I'm going to make a third column for tangent. These should you probably memorize until you figure out about the pattern. Tangent of 60 is radical 3. Tangent of 45 is 1. Tangent of 30 has a whole bunch of 3's in it, radical 3 over 3. That's how I remember tangent of 30, is that 30 begins with 3, tangent begins with a t, and tangent of 30 is the one that has a whole bunch of 3's in it, so the radical 3 over 3. The other way to learn it is using the grid, and I actually like both of them because you get to see different things. 0 and 360. Hope I have enough room for the columns. I have 30, 45, 60, and then I have my quadrantals, 90, 180, and 270. And I have sine, which is the y value, cosine, which is the x value, and then I have the tangent, which is y over x. Not quite, I don't like the way this is working, so hang on. Let me do this over again. Let me do it the other way. Back to pen. So sine, cosine, tangent. That's the y value, that's the x value. That's y over x. At 0, I know it's 1, 0. 90, it's 0, 1. What's the y value? At 0, 0. The x value is 1, so cosine of 0 is 1. And tangent's going to be 0 because it's 0 over 1. 30. So these are the 6 that have the radical 2 I'm sorry, have the 2 on the bottom, the denominator of 2. So 1, 2, 3, 3, 2, 1. Tangent of 30 is one that has a whole bunch of 3's in it. Tangent of 45, notice it's y over x. Anything divided by itself is always 1. And tangent of 60 is the one that doesn't have all the 3's, but it starts with a 3, radical 3. Sine of 90 is 1. Cosine of 90 is 0. Tangent of 90 is undefined, because it would be 1 over 0, and you can't divide by 0. Sine of 180 is 0. Cosine of 180 is negative 1. And tangent, 0 over negative 1 is 0. Sine of 270 is negative 1. Cosine of 270 is 0. And tangent of 270 is also undefined because you're dividing negative 1 by 0, which you can't. You have to memorize those. Be able to recreate it, have it as a cheat sheet on an index card. You have to memorize that. It's hard for me to make sure that you're not cheating on your quizzes and tests. I guarantee you next year in pre-calc, you have to memorize it all over again. So do the best you can for this year. So going back to the review, sine of I copied that down wrong. That should be 210. Right? Yeah, sine of 210. We need a reference angle. And to get the reference angle, I'm going to subtract 180 from 210 to get 30. So sine of 210 is the same as sine of 30. But hang on. So where's 210? 210 is in the third quadrant. And ASTC tells us what's true about sine in the third quadrant. Hopefully you said it was negative. So that means that we'll have a negative sine 30. And then go to your table, either your grid or your unit circle. What's sine of 30? It's a half, so sine of 210 is negative 1/2. Letter B, cosine of 315. I need a reference angle. So I'm going to subtract 315 from 360 to get 45. Your reference angles are going to be one of those three, 30, 45, or 60. Right now, it won't be anything else, especially since we're doing our trig functions. So cosine of 315 is the same as cosine of 45. Wait, double check. What's the SIGN? 315, in addition to being our favorite error code, is in quadrant 4. Cosine is positive in quadrant 4, so it stays positive. What's cosine of 45? Go to your table or your unit circle, and you get radical 2 over 2. And I'm going to skip C for now. I'm going to do the radians later. Let's do letter D. I'm going to try and fit everything here so I can have my grid and my unit circle visible as I'm doing this. 225. I need a reference angle. 225 is in the third quadrant, so I'm going to use 180 to subtract it from 225. Reference angle is 225, so tangent of 225 is the same as tangent of 45. But wait, there's more. You have to find out, is tangent positive or negative in the third quadrant? It is positive, so we don't put a negative sign in there. Tangent of 45, look at your chart. Tangent of 45 is 1. Letter E, tangent of 30. Look at your chart. Look at your unit circle. It's the one that has a whole bunch of 3's in it. Radical 3 over 3. Memorize it. Memorize it. Going back to letter C in radian mode. I'd like for you to see if you can get really, I don't want to be blue. Get rid of that. And change to yellow. Where's my highlighter? Highlighter, yellow. Really want to make sure that you see that pi over 3, that's your reference angle. So that yellow, that's your reference angle, which is 60. The fact that it's 4 60s gives us the angle of 240, which brings us into the fourth quadrant. But wait, there's more, because the fact that's in not fourth quadrant, third quadrant. We're in the third quadrant. Tangent is the only one that's positive. So sine of 4 pi over 3, which is sine of 240, which is the sine of 60, but I'm going to erase that because I didn't leave enough room. For what? For the negative. Negative. Sine 60 Go back and look at my grid or look at my unit circle. 60 degrees sine is radical 3 over 2, so the final answer here is negative radical 3 over 2. All right, so there's question number 1. Number 2, terminal ray of an angle drawn in standard position of a unit circle goes through -6 and negative 6.8, so -6 and 0.8. So somewhere around here in the second quadrant, and it's a unit circle. It's a unit circle, so that means that the hypotenuse is 1, the radius is 1. In the unit circle, cosine is the x value, sine theta is in the y value. So if our coordinates are given as -0.6, 0.8, that means that sine theta is 0.8, cosine theta is a -0.6, our theta is the armpit, our stinky armpit. Tangent, you have to memorize, is sine over cosine. So that's 0.8 over -0.6. You really shouldn't leave it like that. That's 8/10 over -6/10. Keep, change, flip. Tenths cancel, 8 and 6 are both divisible by 2. So -4/3 is actually our final answer for tangent of theta. I'm going to try and squeeze number 3 in here because I want to show you the difference between 2 and 3. Number 3 says the point -512 lies on the circle. Find sine, cosine, tangent. It is not a unit circle. And I'm concentrating on quadrant 2 because -512 is in quadrant 2. So I'm going to draw the right triangle where my base, -5, technically a 5, but it's -5 because it's going to the left. We're going to do some Pythagorean theorem work. 5 squared plus 12 squared is equal to c squared, and you should get that the hypotenuse is 13. Once we have that, notice it's different. This hypotenuse is 13, but in question number 2, the hypotenuse was 1 because we're in a unit circle. In number 3, it is not a unit circle, so we cannot assume the hypotenuse is 1. We actually have to do the Pythagorean theorem to get the hypotenuse. Now I can get sine theta is opposite over hypotenuse. Cosine of theta is -5 over 13, adjacent over hypotenuse. And tangent's going to be opposite over adjacent, 12 over -5. So you want to make sure you know the difference between question 2 and question 3. All right. Got some graphing questions. Number 4. We have 4 equations to graph. None of them have a change in frequency. We all have a change in amplitude or a reflection. So I'm going to see if I can draw them so that you can see the differences. So the first one is y is equal to 3 sine x. Make sure you divvy up your x-axis into the 4 quarters. Amplitude is 3. So we're going to go high 3 and low 3. It's a sine curve. Sine curve, don't forget, is the whole low. So start at 0, go high, 0, low, 0. Connect the dots. Done. Letter B reflects it over the or over the x-axis. So it still has an amplitude of 4, but it's a negative. So that means that after we start at 0, we're going to go swimming with the dolphins. Then we're going to come up because we want to get a snack. We get a snack. Oh, I'm going to go right over my equation here. And then we're going to go back to the shoreline. So it's reflected over the x-axis. So -4 sine x is sine, but it's going to be reflected over the x-axis. Letter C and D are both cosine graphs. Letter C, again, we're going to draw our x and y axis. What's our amplitude is a 2. No change in frequency. That means my x-axis is our typical 4 quadrants. Cosine starts high. You're high and dry, you're getting a little antsy, you want to go swimming. Before you can go swim with the dolphins, you got to hit the shoreline. You get tired of swimming with the dolphins, you're going to come up for a snack. There's your cosine curve. From 0 to 2 pi, amplitude is 2, and it's going from -2 to 2. Letter D is going to look just like letter C, but flipped. We're still going to have a high of 2 and a low of -2. Notice I am putting my scale in every single time. Oops, I forgot to label this one too. Cosine x, this is y equals -2 cosine x. So instead of starting high, I'm going to start low. Shoreline, up high, shoreline, done low. And this is the negative. And because it's flipped. So it's negative, it's flipped, and it's your cosine graph that's reflected over the x-axis. Last question, number 5. Number 5 looks like this. Or I'm sorry, 5a. Make sure you recognize that as a cosine curve. The equation is y is equal to 5 cosine x, because the amplitude is 5. Letter B looks like this. Another cosine curve, but it's reflected. It's upside down. So it should be y equals negative cosine x. Letter C. Starts at the shoreline. So it's a sine curve. They all have a period of 2 pi, so frequency is 1. The amplitude in letter C is 4. It goes up to 4, so it's a positive 4 sine x. Last one, letter D. This is what it looks like. Recognize that as a sine curve, amplitude of 3, but because it goes low first, it has to have a negative out in front. All right, those are the solutions to the review. You folks have a really quick quiz tomorrow that'll be on Classroom. And like I said, like I keep saying, please reach out if you have any questions. And keep reviewing your day 1, day 2, day 3 notes, because we spent a lot of time on graphing. Make sure you can go back and do especially day 3. All right, we'll talk to you soon. Bye.